This video goes over your calculus final review for the free response, the no calculator questions. The first one is a chart. AP loves their charts. So hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t from 0 to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t are here. So use the data in the table to approximate c prime of 3.5. Well, surrounding 3.5 is going to be these two. So we're going to have c of 4 minus c of 3 over 4 minus 3. That's 12.8 minus 11.2 over 4 minus 3, which is obviously 1, but we're going to leave it just like that. Show the computations. That's our computations. And then indicate units. So it's just the units on the top over the units on the bottom, which is ounces over minutes. Okay, using a left Riemann sum with 6 intervals of equal length indicated in the table above to approximate the integral of 1/6 times the integral from 0 to 6 c of t dt. Okay, so we'll first do the approximation. So a left Riemann sum, so we're going to have 1/6 times. We're going to do the widths, which for all of these are going to be 1. It's not always that case. So the widths are going to be 1, and on a left Riemann sum, you're going to go to the left endpoint versus a right Riemann sum, which would go to the right. So we have rectangles. These are the widths. These are the two heights. So we're going to have 1 times the first left point is 0, 1 times 5.3, 1 times 8.8, 1 times 11.2, 1 times 12.8, and our last one is 1 times 13.8. So just keep in mind that the widths might be different, and if they are, we have to deal with that. You have this is a no calculator question, so don't even run the risk of getting this math wrong. Leave it just like this. This part, using correct units, explain the meaning of this. Okay, well, 1/6 times 0 to 6 is the average value formula. Okay, so what this is giving me, 0 to 6, is it's adding up all the different heights and dividing by 6. So the units are going to be whatever the units of C are, which is ounces. So this is going to be the average number of ounces in the cup from t equals 0 to t equals 6. So this number is going to be somewhere in between 0 and 14.5. It's the average of those values. All right, is our estimate a underestimate or an overestimate of the average amount of coffee in the cup? Well, and that kind of gives you a little hint for the answer to this one. Give a reason. Well, this function is increasing. If we have an increasing function and we're doing a left Riemann sum, meaning our endpoints are on the left side, if it's increasing, then there's area left over. So this is going to be an underestimate. So I'm going to say c of t is increasing. So a left Riemann sum is an underestimate. The next question here is our classic given the graph of f prime. So we're given different information. Our endpoints are -7 and 7. We have horizontal tangent lines at -3, 2, and 5, and interestingly enough, a vertical tangent line here at at 3. Okay, so I know I'm going to be answering a whole bunch of questions, so my first suggestion is just turn this into our number lines. Okay, so we're going from -7 to 7. The critical points are where f prime equals 0, which on the graph is where it crosses the x-axis. So -5, -1, and 5. It is 0 here, 0 here, 0 here. You can label these as endpoints. Okay, and then if it is above the x-axis, it is positive. If it's below, our derivative is negative. Here it is positive, and then positive again. So I'm going to label all the things this tells me. It tells me we are increasing here, decreasing here, increasing, and increasing, which means we have a maximum here, a minimum here, and a plateau there. It's going to increase, level off, then increase again. We'll go ahead and do our second derivative while we're at it. So now we're looking between negative and 7 at the slopes of this one, because this derivative is slopes here. So our slopes are 0 at -3. Our slope is 0 at 2. At 3, we have a critical point. So it's 0, 0. It's undefined there, but that's okay. 0 at 5. So for my slopes, we're decreasing to -3, then we're increasing to 2, then we're decreasing to 5, so decreasing, decreasing, and then increasing. So this tells me concavity, concave down, concave up, concave down, concave down, concave up. And we have inflection points anywhere where the concavity changes. Okay, so now we can answer these questions. We've answered all of it in the charts. We just now have to translate that to numbers and justifications. So where is our graph decreasing? Okay, only when this part was below the x-axis, so between -5 and -1. And our real easy answer is because the first derivative is less than 0. These are easy points. So where we have a relative maximum, we already established that's at -5. And our justification is f prime of x switches signs from positive to negative. Okay, make sure you're saying f prime and not it or f or anything. It needs to specifically be the first derivative. Where do we have a relative minimum? We already established that. X equals -1 because f prime switches signs from negative to positive. Okay, and then finally, for what values is the graph concave down? Okay, that's going to be, we've already established, -7 to -3, -2 to 3, 3 to 5. Okay, and our real easy answer is because the second derivative is less than 0. How we arrived at that is the slopes are decreasing, but that's what we're looking for. Okay, for our next problem, we are given an equation in terms of both x and y, and our first task is to show that dy dx equals this. So that's nice. We already know what our answer should be. We just have to do the calculus to support it. This will be an implicit derivative, so with respect to x. So anytime I take the derivative of y, we need to use the chain rule and do dy dx. So this will be 2x plus 4y dy dx equals, the derivative of -1 is 0, but on this part we're going to have to do a product rule. Okay, so leave this side alone for right now. equals 3y plus dy dx times 3x. So we're going to move the dy dx's to one side and the stuff without on the other side. Using this as kind of my guide, we've got the 4y minus the 3x, so I'll do it that way. And then we'll have 3y minus 2x. Okay, so we're getting closer. We'll factor dy dx out. I'll go ahead and switch these around to match, but it wouldn't really matter because it's the same thing. So as luck would have it, dy dx is negative 2x plus 3y over 4y minus 3x. Okay, the second part of this problem, at the point 3, 2, the tangent line is horizontal. Find the value of d2, the second derivative at that point, to determine if the curve has a local maximum or neither at point P. Justify your answer. So now we're going to do the second derivative of this. So we're going to again need to use, well, this time we're going to have to use the quotient rule. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the denominator squared. Okay, so we'll do those derivatives implicitly again. So we're going to have negative 2 plus 3 dy dx. This is going to be 4 dy dx minus 3. Okay. Then we're evaluating this at the point 3, 2. So if you plug 3, 2 into this, dy dx is 0. If we were just asked for the second derivative, I didn't mark that, we'd have to substitute back in this equation in for these guys. But here I'm just evaluating at our point. Three, 2. So we're going to plug 3 in for x, 2 in for y, and 0 for dy dx. So it's going to be negative 2 plus 0. 4 times 2 minus 3 times 3 minus 4 times 0, so negative 3, negative 2 times 3 plus 3 times 2. Over 4 times 2 minus 3 times 3 squared. So we're just going to be real careful with our math here. This is going to be negative 2. We're going to have 8 minus 9, so that'll be negative 1, minus negative 3. Negative 6 plus 6 is 0 over 8 minus 9 is negative 1, negative 1 squared. So this is going to be 2 over 1. Okay, so we got our value. It says, does the curve have a local maximum or neither? Well, if the first derivative is 0 and the second derivative is positive, which means it's concave up. If we have a concave up graph and we have a slope that's 0, this is going to be a local minimum. So a local minimum, because dy dx equals 0 and d2y over dx2 is greater than 0. That would be our justification. Now we have an integral function. So we have a semicircle and two line segments. And our function is g of x equals the integral from 0 to x of f of t. So g of 3 is going to be the integral from 0 to 3 of f of t dt. Okay, so that's going to be from 0 to 3. So it's going to be this quarter circle, pi r squared, the r is 2, 1/4 of that, minus, because this is below the x-axis, the area of that triangle. Okay, now you can leave it just like that. This does cancel to pi minus 1/2, but that's acceptable. G of -2 is going to be the integral from 0 to -2 of f of t, which is awkward. So we're going to rewrite this as the opposite of the integral from -2 to 0. So if I'm going from -2 to 0, that's going to be this. So that's positive area, but that's going to make it negative of, same thing we did here, 1/4 pi 2 squared. So this is negative pi. Okay, find the instantaneous rate of change of g with respect to x at 3. This is just a fancy way of saying the derivative. So g prime of x is just f of x. Okay, if I do the fundamental theorem here, the derivative of this is just f of x. So g prime of 3 is f of 3, which according to my graph is -1. Okay, find the absolute maximum value of g on the closed interval -2, 5. Justify your answer. The justification is the work in that I'm deciding I need to do our candidates. So my endpoints, g of -2, we already did, was -pi. G of 5, okay, is going to be the integral from 0 to 5.
Good morning.
Okay, g of 5, we've actually already calculated because we did g of 3, which was all of this. If I were to add on this and this, they actually cancel each other out. So this is the same as what we found here, pi minus 1/2. Okay, and then the critical point, our only critical point, well, we have two critical points, g of 2 and 4, because that's where our derivative is 0. G of 2 is going to be the integral from 0 to 2, so that's going to be pi that we've already calculated. G of 4 is just going to be that minus this area, so -1. Okay, so where is our max? Find the maximum value. The maximum value of all of these is pi. The justification again is that we've taken out our candidates. Okay, the last part of this problem, the second derivative is not defined at 2 and at 3. Okay. How many of these are points of inflection? Well, points of inflection, as long as we have a value on this graph and the second derivative changes signs, which means the first derivative changes from increasing, sorry about that, increasing to decreasing. So of this, it goes decreasing, decreasing. So here at x equals 3 is a point of inflection. Okay, because g double prime of x changes signs. Okay, because this graph goes from, because we're looking at the slopes there. Sorry. All right, so we have a lot of information here. We have f, we have values at certain points, we have f prime, g prime. We have whether in between these ranges we are positive and negative, and we're going to use that to answer some follow-up questions. So find the x coordinate of each relative max of g on the interval -2 to 3. Well, let's look at g prime of x. Okay, the critical points, there's only one here at 0. Less than that, our graph is positive. After that, it's negative. So the x-coordinate of any relative maximum is going to be at x equals 1. Because g prime of x switches signs from positive to negative. Okay, explain why there must be a value c from -1 to c such that g prime equals 3/2. Well, this is asking for the mean value theorem. Okay, so I'm going to look at g of 1 minus g of -1 over 1 minus -1. Okay, g of 1 is 0. Sorry, g of 1 is 3. G of -1 is 0 over 2, so that's 3/2. So our justification, G is continuous and differentiable so by the mean value theorem, G prime of C must equal 3/2 on -1 to 1 on that interval. All right, the function h is defined by the natural log of g of x. Find h prime of 3. So we're going to start by finding h prime of x, which is going to be a chain rule. Derivative of natural log is 1 over x, so this is going to be 1 over g of x times g prime of x. So h prime of 3 is going to be 1 over g of 3 times g prime of 3. Well, g prime of 3, go to our chart, g prime of 3 is -2, and g of 3 is 1. So this is going to be 1 over 1 times -2, which is -2. All right, evaluate the integral from -1 to 3 of f prime. This is going to be the fundamental theorem, f of 3 minus f of -1. So from the chart above, f of 3 is 7, f of -1 is 8. So this is -1. Okay, this one is going to be f prime of 3 minus f prime of -1, because the antiderivative of f double prime is f prime. Okay, again, carefully from the chart, you get 1/2 minus 0, which is 1/2. Okay, this last one's a little bit tricky, but we're just going to do a u substitution here. So I'm going to let u equal g of x. Okay, evaluate our endpoints. G of 1, according to my chart, is 3. G of -2, according to my chart, is -1. Okay, du is going to be g prime of x. So this integral is rewritten as the integral from -1 to 3 f prime u du. Well, that's just what we did up here. F of 3 minus f of -1. Still 7 minus 8, still -1. So those are your no calculator free response questions for your final exam.